Hello, today we'll be doing an AP Physics C response from 1993, number 2 in mechanics. A car of mass m, initially at time t equals 0, is driven to the right along a straight horizontal road with the engine causing a constant force F to be applied. While moving, the car encounters a resistance force equal to negative kV, where v is the velocity of the car and k is a positive constant. So first, I will write down all of our knowns. Mass equals m. A constant force of F equals force by engine. And negative kV equals resistance force. There's really no other information that we need to know. And just keep in mind that it starts at t equals 0. Part A says, on a dot representing the center of mass of the car, draw and label vectors to represent all the forces acting on the car as it moves with the velocity to the right. So, for part A, they want a diagram, a dot diagram. Going to the right is a positive force F initial, which is the force caused by the engine, and then on the other side, counteracting it, is negative kV, which is a resistive force, but because we change the sign, the negative becomes positive, and it's positive kV. There is a normal force going up, and then weight going down, mg. And there's only those 4 forces acting on it, so this part is pretty simple. Part B. Determine the horizontal acceleration of the car in terms of k, v, f initial, and m. Okay, part B. So we'll just go to the sum of the forces equals ma. MA equals F initial minus KV, because we're only looking at the horizontal components, and there's F initial and then KV opposing it. So A equals F initial minus KV divided by M. That was just a simple PHYSM situation. Part C. Derive the equation expressing the velocity of the car as a function of time t in terms of k, f initial, and m. So they want velocity, and they want us to find, they kind of give us a clue where they tell us to find it using a acceleration. So we set up the equation, and acceleration and velocity are connected by dv dt equals a. So dv dt equals a. And that's where we start from. However, a, as we found in part B, is equal to f initial minus kv divided by m. So we can do separable integrals and divide out on both sides, and we'll get that the integral of dv divided by f initial minus kv is equal to the integral of 1 over m dt. So this is where we are right now in the integration. Part C is the orange, And that sort of seems like a dead end, and it might be confusing as to where to go next, but in situations like this, we usually almost always see U substitution. So, what if we want to come up with a good U substitution, we need to kind of figure out what part of the problem we kind of want to simplify. So the one thing that stands out to me is F initial minus KV. So we can just substitute that entire expression for U. And if F initial minus KV equals U, what is dV equal to? Because we want both of those variables in terms of the same variable, I guess. And so du dV is going to equal negative k. You can see that just by taking the integral of F initial minus KV equals U. And therefore du equals negative k dV, and dV equals du over negative k. So we take the newfound quantities, plug it back into our equation, and we get that the integral of 1 over u times 1 over k negative du equals negative 1 over k times 1 over u dt. And from there, we have that entire equation is equal to 1 over m integral of dt. So this is what it looks like after the substitution. After that, we can start solving the integral, and there are no limits of integration, so we'll have to keep in mind that there will be a constant, and 1 over u and 1 over m kind of both hint at the ln, because that's the only rule that can be applied in this instance. So the ln of u minus the ln of c is equal to negative k m t. The integral of dt is simply t plus c, but we're gonna add plus c, and we can combine ln of c and plus c to come up with a different constant called c initial. And then ln of, we'll plug in u, which is f initial minus kv, equals negative k over mt plus c initial, which is the big C. C initial equals ln of c plus c. And then afterwards, we're not going to want to leave the equation like this because we're looking to isolate v. So we can, let's see, what can we do here? I guess we can just take raise both sides to the power of e, and that will get rid of the ln for us. F initial minus kb equals c times e to the negative kt over m. and then negative kV equals negative F initial plus C times E to the negative KTM. And the reason you can multiply the C in here is because, the reason you can multiply the C in over there, right there, is because it's a constant, and when it's raised to the E to the C can just be another constant that we can multiply, because, and we'll actually call that C1. And so ultimately V is equal to 1 over K times F initial plus C1 times E to the negative KT divided by M. And in order to find C, we realize that at T equals 0, V equals 0, so C equals F initial. Because 0 equals K times the quantity of F initial minus C times E to the 1, E to the 0. So when you look at that, effectively you get that C is equal to F initial. Okay, so using that we can just get final answer. V is equal to F initial over K times 1 minus E negative KT divided by M. We factored out an F initial, and this is the final answer. Alright, thank you very much.